Hello and welcome to another AP Computer Science video. This video is going to focus on strings and their functionalities. We've seen strings as very simple ways of keeping multiple characters, and today we'll be able to see how we can do a lot more with them if we remember or learn about the different behaviors that are associated with them. Strings we mentioned before are not primitive data types, so they do have not only data but also behaviors connected to them, and that's a pretty big difference between primitive values, for example, as chars, single characters, or ints or doubles. So strings will give us a lot of power, and we can do a lot of complex work with them by using those behaviors. So we're going to try some of those things out today. I'm going to make a new Java class in my package basics. If it lets me, there we go, new Java class. I'm going to call my class string stuff. So we're just going to talk about different string functionalities, behaviors, what have you. Let me get rid of my comments. Okay. Let's make a main. I'm going to use a shortcut. So the first thing I'll do is I'll make a string the way we first saw, which was using a string literal. So our data type is string. We'll call our variable str, and we'll initialize it right away to something like Jimbo. And so string literals, if you don't remember, are always in double quotes. They can have any character. They can have 0 characters. They can have more than 0 characters. And special characters, escaped characters, can also fit inside. So if we want, for example, a literal double quote, we'd have to put a backslash quote, or if we want a single quote or a backslash, things like that. Strings allow us to do all the things that chars do, but multiple characters at once. And so that on its own seems good, and that might make us believe that they're just the same as primitives and that all they hold is content. But one recognition of the fact that they're not primitive is the type is not recognized as one of these orange keywords in the language. It is a class type variable as opposed to a primitive variable. And essentially what it means is it's not just data but also functionality associated with it and all the kind of workings that need to exist for that to happen. And we are kind of hiding a lot of those details, and the language does what it can to minimize our need to know some of those ugly details. But what we can take away from it is that from the variables that connect to a string value, we can call functions, or what we'll call methods, and I'm going to write these notes in a moment, what are called methods, to make actions happen either on the string or generate results from the string. And so we'll start with, before we start with the actual methods, we're going to start with another way of creating strings, which may seem odd, but essentially gives us an ability to make copies of other strings. This is one way we can make a copy. So we can say something like string copy is equal to new string and then str. And we'll talk more about what these things do, but what we'll do is we'll call this a string constructor, and we will see more about constructors in other classes and how we can make our own. But for now, we'll just say that we could actually, and this is an older style, and you can see that NetBeans is trying to warn me, like, you don't have to do this, which is, I think, pretty reasonable. But the idea is that we don't have to, if we want to make a copy, we can do so by doing this. And this is kind of a hard thing. So now if I refer to copy or print copy, it is a duplicate of Jimbo without being Jimbo. And so if we talk about the RAM that's managed by the computer, the RAM that's holding the literal Jimbo is not the same RAM that's holding the copy. And so that way you might say, well, why would that matter? And the answer is, typically if we have content that's controlled by the computer and RAM, if two variables are looking at the same content and you change one, the other one will see the change. That's not going to be true here, and we'll talk more about this again in detail as we get into making our own data types. We'll see that we have a lot of control over that kind of aspect. So we're more concerned with just being able to make strings and use strings. This is not something that I've done very often. Almost always either a string is generated from literals or other content maybe read from a file, brought in from somewhere, or combined by making empty strings or loading different things. But the constructor is a pretty rare thing, so we can put that. We'll say something like copies of strings can be made using a string constructor. We'll talk more about constructors in a future video, and this is a pretty big deal, even though we don't use the string one very often. I pointed out, but the AP exam thinks that you should at least be aware of the fact that you can make a copy of a string by using the constructor. And more useful functionality. And so what I'm going to do is I'm going to start saying that instead of calling them functionalities or functions, even though they very much are like mathematical functions, we're going to use the Java term method. A method is basically some form of behavior, that an action that can be run from or created from a piece of information. And those pieces of information are typically non-primitive objects. And string is one of these things. So for example, if I'm curious to know how many characters are in a string, there's a special method that allows me to know that. And so let's go ahead and put some notes and say methods are behaviors or functions that exist within class type variables. So strings are not the only objects we're going to see. They're not the only class type data types we'll see. We'll see many, and we'll eventually be able to make our own. And they do eventually boil down to a collection of primitive values, but the way it's going to work is that we can see it from that top level string, and we can call these methods, use them very much how we use the math functions. We talked about math at absolute value, math at square root. Those are methods. How they're called is a little bit different than how we're going to be calling string methods, but that's only because of the fact that there is no math thing, right? A string is a particular set of characters. Math is like a kind of category. It's not necessarily an object like a string might be, and so those functions or methods are kind of loose on their own under one umbrella name, math. Strings represent individual objects that may contain 0 or more characters and have their own functionalities. They're context sensitive, the context of what characters happen to be in it. So, as an example, you might say, int length is equal to, and now how can I know how many characters are on? Again, I can count it because I wrote the literal, but if this came from a variable of unknown size, we just had the name of the variable, we could still do this as long as we knew it was a string. And the way we might do this is saying str.length. And length is a method, and so I'm going to write some notes about method notation. We'll say methods are called using dot notation. And we've been kind of using it sometimes implicitly and not really thinking about it, and you maybe just been copying, but now we're going to be a little more formal and say dot notation is when we have usually a variable, the actual dot or period, and then the name of the method. Right? So typically dot notation is of the form, we'll say variable dot method name, and then parentheses. And so we'll talk more about this as we go on when we make our own, but essentially the parentheses are for any arguments or parameters to the function that may exist. And we'll see that some contain inputs or need inputs, some do not. And again, it's about the context of what we're doing. And so in this example, the length method does not require input. Instead, it merely says, well, I'm going to count how many characters are inside of the string that called this method and return that value as if it were a number, and then we can do what we want with that number. And length does return an int because you can't have 0.75 characters. You can have 1 character, you can have 0 characters, you can have 10, but you can't have a decimal amount of characters. So we'll say returns the number of characters in the string. This method does not have any parameters. But when we call methods, we usually need to put what's called the parameter list of the parentheses anyway, even if there is no input. And so this is not maybe something you would do in math, right? In the example of, we say a function f exists called, we would write as f of x equals x plus 5. The x is the input, and so would we ever make a function in math that doesn't have an input and just gives a constant function? F equals 5. That's, I guess, a constant line. That might be something we'd do, but it would be kind of uncommon, I think. And so here, sometimes methods have enough information that they can just do what they do, and there's no need for extra input. Others need input from the program or the user of the method, and then they can generate meaningful results, and depending on those inputs, they may generate different results. The length is very much, it has enough information internally stored in the string to calculate how many characters there are. We don't have to say anything extra to it. So if I go ahead and print this, and I say print out length, we should see, if we count, the last str had the literal Jimbo 1, 2, 3, 4, 5. We should see the number 5. And there it is, number 5, right? So the idea is that the length returns the number of characters. So if I were to go and reassign the value str to an empty string, and remember we mentioned empty string is a string that contains no characters, then we would expect the length to return 0, to print out 0. So I'm going to do the same thing. I'm going to say length is equal to str.length. And so since the new str is an empty string, when we print this, we expect to see 0. Again, an empty string may seem odd, but it is a valid string and therefore does have a valid length. And the result is size 0. So if someone made a string and we don't know what it was, and we wanted to say, well, how many characters does it have? We could call this length method and then get the result of the number of characters. Right? This is a useful tool to have. We could maybe sort a bunch of strings by the number of characters they have. And so knowing how many there are could be very useful to us. So that's a pretty easy method to use. Another method that's useful is to compare strings. And this is something that we're going to see more of as we go on, because it's a big issue. We've seen comparisons in our last videos with the relational operators, right? Is one thing smaller than another thing? Are they equal or not? And there are two methods that strings have to allow us to know that information. One of them is kind of a simplified version. It just says, are these two strings equal to one another? And so this is called the equals method. So we're going to say the equals method returns true if the input string is the same as the calling string. So we'll talk about what that means. So as an example, I'm going to make a second string, and we'll call it second is equal to potato. So if I call the method, how do I call the equals method? The equals method is the same dot notation. It's going to be a variable, the caller, dot, and then the word equals, and then the input to equals is a string, right? So I should write that. The input to equals is a string value. So let's see how that looks. So I might say Boolean same is equal to, and again it returns a Boolean value, and so it returns true if the input string is the same as the calling string, and I'll put false otherwise, right? There's kind of only those two choices. So we might say str, which is the caller, and again I could have any string call this method. All strings have the same methods accessible to them, and they always refer to the context of their own information. So str refers to Jimbo, second refers to potato, and then their methods will reflect based on those characters. So if I str equals, and I put second, this is a true or false statement. Either it is equal to second or it is not. And the way it determines equality is if every character is exactly the same. This is a case-sensitive method. That means that if there's a capital letter, and if that's the only difference between the two strings is a capital letter, they are different strings. So I need to write that as well. It's important to recognize. Equals is case-sensitive. We can prove this in a moment. So I'm going to go ahead and run our, let me go ahead and print out whether they're the same. So we'll say something like, oops, we'll say something like, let's go and concatenate the result. And let's go ahead and run it. And the answer is no. Are they the same? No, because one is the string capital J Jimbo, and one is the string lowercase potato. Now, could we test this again and see if it works? Sure, we could say something like same is equal to str dot equals copy. Remember, copy supposedly makes a direct copy of every character inside of the original string. So in this case, str. So if that's the way it works, then we expect the original string str to be equal in terms of characters to the variable copy. So let's go ahead and see if that works. And we should see true. And they're not, and so we have to kind of deal with that fact, and why is that the case? And unless I did something wrong. No, str. Oh, I know. I'm sorry. It's a mistake on my part. It wasn't comparing Jimbo. It was comparing empty string. I forget that I erased it to be what it was. So let's fix that. Otherwise, it's going to kind of be a problem. I realized that was a mistake on my part. So let's go ahead and do that. let's say str is equal to Jimbo. So I'm assigning a value. I'm going to go ahead and run it again. We should now expect them to be equal to each other. And there it is, right? The copy of the original str was Jimbo. We changed str to empty quotes, which didn't affect the copy. And then I unfortunately forgot to change it back, and so it ended up being false. But now that they're back to being the same letters, letter for letter, they are the same. And so now let's go ahead and change this to a lowercase j and see if it ends up being a true or false. I'm going to run it. And there it is, false, right? Capital letters, and we saw this when we were comparing chars. The same idea holds. In fact, the way equality of strings is determined is character by character. So every char is looked at one by one, and as soon as a difference is found, we can say they're not equal. And if no differences are found, then they are the same exact string. And so in this case, now that this is a lowercase j, they are not equal to each other. And if I put it back to a capital J, they will be equal to each other. So equals is a great way to make a decision about are two strings equal? Because unfortunately, we cannot use the equal operator. And this is very much a technical reason. Essentially, when you use the equal operator on a non-primitive value, you are not comparing the content, but instead, as strange as this might sound, you're comparing the memory address, the memory location in RAM of the variables. And unfortunately, that might not work out so great, right? They may have the same content, but if they're not in the same location, then that's a problem. And in fact, I'll go ahead and test it, and we'll see that this is kind of a very strange thing. But if I go ahead and say same is equal to second equal str. Right? In fact, it even warns me. We can actually read the warning. It says comparing strings using equal or not equal, it's not a good idea. It's not even an error. It's just saying you shouldn't do it. It's just a warning. And the reality is we're comparing memory addresses. And so here, we might argue, well, we know they're different, and so they're probably going to have different memory locations. So we expect to see false. Oh, I didn't print it. Let me go ahead and print it. So we expect to see false for our third print. And there it is. Now, let's try this. And this one, we'll have to see what it is. Let's try str equal to copy. And let's see what happens. They're not the same because a copy is given a new memory address. And now the last thing I'm going to do is I'm going to try doing something like this. And let's see if this happens to work out the way I expect it might. So a new string, and we'll call it Jim is equal to Jimbo. And so we can see that the string str is equal to Jimbo at this point, and now Jim is equal to Jimbo. Right? They're two different variables, so we might think that they have different memory addresses. Let's see if that's really the case. Go ahead and copy it, and we'll compare it, and then we'll also copy our print, and let's see. And they are still distinct. Oh, I'm sorry, I should have compared Jim to str. That's, again, I'm just confusing myself. So Jim to str, are they the same, right? And actually, they are the same. And this is not just the same in terms of content. This is the same memory address. And this kind of brings up, again, one of these things that if you don't really pay attention to some of those details, you might not ever notice it. And it may not be a big deal, but it's something we should be aware of. Any string literal that has the same value, the compiler, to save on RAM and to be smart and save space, tries to refer to the same memory address. It says, well, Jimbo's kept in position XYZ, and some other string wants to make a copy of the same capital Jimbo. Why make a duplicate and put it somewhere else? Now we have two spots in memory that are taken up by the same word. Let's just look at the same location. Let's just look at literally the same words. And so that whole confusion of are we looking at the memory address or the content is why we don't use equal comparisons on non-primitive values. With primitives, it's not an issue because what we mentioned, the main reason we call them primitives is the content is directly stored in RAM. In this case, for strings, since they're not primitive, that is not the case. And so some of those kind of behind-the-scenes management issues can pop up if we're not paying attention. So we do not compare strings with equal. We only use the equals method. And that says, yes, they're the same, or no, they're not in terms of content. Right? So I'm going to go ahead and put a note here, and just so we're aware, this is a very dangerous idea, right? Do not compare strings using equal or not equal unless you mean to compare memory addresses, which is most often not the case. Right? Very rarely will we have a reason to do so. So we should be using the equals method, right? Okay. So now another method that's useful, that's related to equals, because equals just says are they the same or not. But I might want to know, is one string before another string in terms of some kind of ordering? And we have the ability to make this decision with a special method called compare to. So let's go ahead and write another note. We're going to say the compare to method. And again, methods follow the standard, and since we're not writing our own, we're just using theirs, the Java people follow the standard of camel case as well. So notice their compare to, since it's two words, the second word is capitalized. So the compare to method. This one's a little bit strange. It gives us more detail than equals does. So it returns a negative value if the caller is, and I'm going to put this in quotes, smaller than the input, a positive value if the caller is larger than the input, oops, and 0 if they are equal. And this may seem very strange, but essentially what it boils down to is we can order strings based on their characters. Now, I could call it alphabetical order, but that is not accurate because it's not just the alphabet. We can see strings can contain numbers as well and symbols and all kinds of things and escape characters and all kinds of things. And so the official term I believe we're going to use is lexicographical order, right? So I'll put this note. String order is lexicographical. I believe that's the word we're going to use. And it basically means, and a lexicon basically is like your collection of words or characters that you use in your language. And so it's essentially alphabetical, but including symbols that have an order. And in reality, it's basically according to the Unicode table, the same table that we saw for characters. That's the reality. So a capital word, or a word that has a capital letter initially, may be considered smaller than one with the lowercase because the capital letters come before the uppercase letters. I'm sorry, the lowercase letters. And so that's how we can determine that. And so if we really needed to know, if we were going to make the choice to compare weird symbols and give them an ordering, then it would be totally dependent on the Unicode table behind the scenes. So we're really just about the characters themselves, and that's more useful, so we can try some examples with characters instead. So let's go ahead and I'm going to make some more strings just so we do. So I'm going to call one str1, and then is equal to, and we'll go ahead and put the word apple, and then we'll say string str2 is equal to banana. So we'll start off with some simple words. And now compare to, how do we call the method? We're going to say, and it returns a number. So these numbers, and it's positive, negative, or 0, so these are whole numbers, and so we're going to use int as our value to store it. Then I'll call it CMP for compare. So here we're going to say, I'm going to do str1 dot compare to, and I'm going to compare it against str2, and then it's going to return a number. And so what I'll point out is that it mentions caller and input. The order matters. If str1 calls compare to, that is not the same as str calling compare to, and we'll see that in a moment. So I'm going to go ahead and print out this value. So we'll say CMP equals, and then we'll attach whatever CMP is. And so lexicographical, we'll take it as alphabetical, so apple is going to be quote-unquote smaller than banana. Why? Because the A in apple shows up before the B in banana, right? And then the alphabetical order. So let's go ahead and run this, and we should see a negative number. -1. Why is it negative? Because apple is before banana if you had to put them. And the way it's going to work is it actually goes character by character, and it says, okay, are the characters different? What is the difference? And that's the result we do. If I look at the letter A, is it smaller than B because they're different, then it must be a negative number. If they happen to be the same, so for example, if I did anana, which one's going to be smaller? So for A's, they're going to match, So they'll move to the next character, and they'll say, okay, P versus N. Which one comes first? And so N is smaller than P because it comes before in the alphabet, so we expect to see a negative number again because the P is going to be smaller than the N. No, I'm sorry, a larger number. It's larger. It's going to be larger because P is after N. I'm sorry, I confused myself for a moment. And there it is, positive 2. Now, the question might be, well, how did I get negative 1? How did I get negative 2? And are we going to see different numbers? And this is why I was vague. I just said a positive or negative value. It does not matter what the number really is. Generally speaking, we don't look at the number and print it out. We just make comparisons. We say, hey, if you're less than 0, you must have meant you're smaller. Hey, if you're greater than 0, you must have meant that you're larger. And if you were 0, then you must be the same. So we're going to go ahead and try this out again. And let's do the same thing, but let's reorder our printing. So let's say str2 compared to str1. Same strings, apple and anana, but the reality is instead of getting positive 2, we're going to end up with negative 2 because we're comparing the A's match up, and then we see N versus P because the N is the second one, and this is saying, is N smaller than P? Oh, it is. Then return a negative value. So the caller and the input, the order, is extremely important. So let's try another example. Let's do apple and capital Apple, right? And see that it is very case sensitive. So we'll do the same thing. And now what we'll do is we'll compare str1 versus str2. And so we're saying apple lowercase versus apple uppercase. So if we remember our Unicode table, we should hopefully remember that lowercase letters are always larger than uppercase letters. So technically speaking, apple in lowercase happens after capital Apple, so we should see a positive number. It's going to be larger. So let's see. And there it is, positive 32. Right? These became negative and positive just because I forgot I switched them after the fact. So maybe I should go back to... Or actually, let's do this. Let's copy these lines. We'll make our changes after the fact. So these will be apple and apple, and then these will go back to apple and banana. Right, so if I run these now, we see that apple, when apple was the first comparator, then A was smaller than B, so we got a negative number. When B was being compared to apple, then we got a positive number. And in this case, the lowercase letters are are larger than the uppercase letters, and therefore we get a positive number. And so that's what we have. And now if I flip them, then we would see negative 32. Now, again, where are these numbers coming from? If we really wanted to know, it's the difference between them. And I mentioned last time as well that characters have a numeric value. So the capital A is, I believe, the number 65, and the lowercase a is the number 97. 97 minus 65 is 32. That's where the number comes from. And we can prove it again because if we look at A and B, if A is 65, if A is 97, B is 98, what is 97 minus 98? Negative 1. What's 98 minus 97? Positive 1. So again, we don't really need to know the number, but if we're curious, it's essentially the subtraction of the two characters. And again, we saw that characters are basically numeric values. And so it's as easy as saying, if you see a match, move on to the next set, next pair. If you see a difference, subtract, and then that's the number you return. And if they're the exact same word, so let's do one last try. Let's do this. Right? Then we would, let's go ahead and put apple and apple. Then we should get 0 as our answer. And there it is. Because if you think about it, if we went character by character, the difference is A minus A, which is 0. Because 97 minus 97 is 0. P is whatever number it is, minus whatever number it is 0. P and P is 0. L and L is 0. E and E is 0. The result is, if you could manage to get through both strings and get 0 every time, then the entire string must have been exactly the same. And therefore they are equivalent, and compared to does that. So we can use this to order things. We're not going to use it just yet. We're not there because we're not able to ask questions yet, but we're getting very close to the ability to make a decision based on this information. And so this is a very powerful tool to have. We can just say, are they equal, using the equals method, or if we want to know more details, we can use compare to. And we could also technically use compare to in the same fashion as equals, because when compare to returns 0, then we would say the result is they're equal. Right, so we can use that to our advantage, and we'll use these more as we go along. This video is going to stop here. We'll continue with some more string methods in our next video.